take that center off of 0 when you're generating your polynomials, it's no longer called a Maclaurin polynomial, it's called a Taylor polynomial. So again, a Taylor polynomial is going to happen when the center is not necessarily at x equals 0. So that x sub 0 subscript is just that notation meaning the center. So a Maclaurin is a type of Taylor polynomial. It's just a Taylor polynomial with the center at 0. So if they ever tell you Maclaurin, then you have to remember that that is where the center is at x equals 0. If the center is anywhere else, they will have to tell you what that particular x value is. So if you want to generate a Taylor polynomial when the center is not at 0, then the Maclaurin polynomial, the Taylor polynomial is going to start at f of x sub 0 plus f prime of x sub 0 times x minus x sub 0. So basically you're going to have to subtract. Again, in the Maclaurin polynomial, we didn't write x minus 0 because that's just x. But now what's going to happen is inside the parentheses, you're going to see that x minus x sub 0 plus the second derivative at x sub 0 times x minus x sub 0 to the second power all over 2 factorial. And as you can see, it becomes really tedious to write those, the derivative hash marks. So that's why you're seeing in that notation it's okay to write the subscript, the upper index, as what derivative you're actually having. So this represents the third derivative at x sub 0 times x minus x sub 0 to the third power all over 3 factorial. Now, when you're dealing with polynomials, because we'll talk about your power series later on, polynomials have a definite end. I know we've been used to looking at the infinite series now for several weeks. Polynomials have a definite end. So when you're writing your Maclaurin and Taylor polynomials, you must write this plus dot 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 plus. And a lot of times they're going to ask you for the nth polynomial, which means you have to write the general term. So this would be that plus f to the n x sub 0 times x minus x sub 0 to the n all over n factorial. Okay? Sometimes they'll tell you exactly how many terms they want. Sometimes they'll want you to generate the Maclaurin or Taylor polynomial out to the nth term. That means you're going to end with that general formula. That's the formula that we will use to generate each term in that particular polynomial. Like I mentioned, Maclaurin polynomials are special cases of Taylor polynomials in which the center is at 0. So, like I said, a Maclaurin polynomial is a type of a Taylor polynomial. So any theorem that we talk about for Taylor polynomials will apply for your Maclaurin polynomials as well. So any theorem that we talk about. So when we're talking about Taylor, and of course that also refers to Maclaurin, they may talk about terms, order, or degree. So what is a term? So vocabulary word in math you've probably heard since pre-algebra. How can you know the number of terms in a polynomial? We established what a polynomial was. We had to go over several times what a polynomial was. But now, how do you know if I ask you to write out 5 terms? How do you know when to stop? What are terms separated by? Terms are separated by what? Addition and subtraction signs. So remember, terms are separated by addition and subtraction. Multiplication is the glue that holds a term together. Addition and subtraction breaks up the terms. When we talk about order, that's a new vocabulary word. We talk about the order of a Taylor or Maclaurin polynomial. It's the number of derivatives needed to form the polynomial. So in other words, if the question asks you to write a 4th order Taylor polynomial, that means you need to take it out to the 4th derivative. So it's the highest derivative in the polynomial that was used to generate it. That's what order means. And then, of course, we talk about degree. Degree is the highest power in the polynomial. So another word we've looked at quite a bit is being able to find the degree. You look at the largest power for x. So here's an example. Here's the first 4 terms of e to the x Maclaurin polynomial. So again, how many terms are in this particular Maclaurin polynomial? 4. What's the degree? 3. What's the order? What was the highest derivative that was used to generate this particular Maclaurin? 3. Degree and order may not always necessarily be the same. A lot of times they are, but sometimes they're not. So let's take a look at the second example, cosine of x. So here's your Maclaurin polynomial for cosine of x. The number of terms, how many terms are in this Maclaurin polynomial? 3. What's the degree? 4. Now let's talk about the order. There's two possibilities what this order could be. What could it be? Well, the most obvious one, it would be a what? 4th order. But could this very well have gone out one more term? Yes. So this could have been a 4th or 5th order. And the reason why you're not seeing that term is because we know that it was a 0 as the derivative for the 5th derivative. So this is an example where order could be classified differently than the degree. This could be considered a 4th or a 5th order Maclaurin polynomial. All right, so let's take a look at an example. Let's start talking about Taylor polynomials. So find the first 4 Taylor polynomials for natural log of x about x equals 2. So when they ask you to find the first 4 Taylor polynomials, that's really asking you for 4 terms. That's another way of them asking you about terms. So in this particular Taylor polynomial, we're going to write out the first 4 terms. So again, always, always, always get in the habit of writing out the formula for what these Taylor polynomials are going to be. So again, the center is at x equals 2. So when I want to generate this particular Taylor polynomial, I know it's going to start with f of 2 plus f prime of 2 times x minus 2 plus, so there's my 1 term, 2 term, the second derivative at 2 times x minus 2 to the second, all over 2 factorial, plus the third derivative at 2 times x minus 2 to the third, all over 3 factorial. It's not asking me to end with the nth term. It's not asking me to find the general term for the Taylor polynomial. So I don't have to worry about putting that plus dot 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 plus ending with the general term. It's just asking me specifically for the first 4 polynomials. You've got to read them carefully because if you tack on too many, they will take off. Part of it is knowing that you understand what degree versus order versus terms are. So make sure you're reading them carefully. All right, and if they want the general term and you don't put it in there, obviously that would also be a reason to get the points taken off. So just like you had to do with Maclaurin, first of all, off to the side here, I know that f of x is natural log of x. So then I'm going to want to find what f of 2 is. So f of 2 is just the natural log of 2. So now I'm going to find the derivative of natural log of x. And what is the derivative of natural log of x? 1 over x. So then f prime of 2 is going to be what? 1/2. So now I need to find the second derivative. So I have to take the derivative of 1 over x. So what is the, remember, that's really x to the negative first. So 1 over x is actually going to be what? The derivative. Negative 1 over x squared. So then to find the second derivative at 2, that's going to be negative 1/4. The third derivative of x, watch your signs. What's the third derivative going to be? Is that numerator a 1 or is it going to be a 2? 2. So it's going to be 2 over x to the third. Because remember, I rewrite this as negative x to the negative second. So again, using your power rule, I'm going to bring that negative 2 and multiply it by negative 1. So then the third derivative at 2 is going to be what? 2 over 8, which will simplify to 1/4. So you have to find these values first so that then you can go back and you can substitute them back into the Taylor polynomial that we've started to generate. So now, what degree is this Taylor polynomial going to be? This is actually going to be a Taylor polynomial out to what degree? third. So that's what this subscript right here represents. That represents it's going to be a third degree Taylor polynomial. So P sub 3 of x is going to be equal to, we found f of 2 to be natural log of 2, so I'm going to plug in natural log of 2 for f of 2, plus I found the first derivative at 2 to be 1/2, so that's going to be 1/2 times x minus 2. The second derivative at 2 was negative 1/4, so this is going to be minus 1/4 times x minus 2 squared all over 2 factorial. You do not need to multiply, and in fact, I'm going to encourage you, do not multiply out the factorials. All right? And multiply those denominators together, because if you make a mistake, you're going to lose points. Whereas if you leave it alone, you'll be fine. Plus, and then the third derivative at 2 we found to be 1/4, so that's going to be 1/4 times x minus 2 to the third all over 3 factorial. So there is your Taylor polynomial for natural log of x with the center at x equals 2. Remember what that center means. That center means that that is the one point on the graph for natural log of x and for this particular polynomial that have the same point in common. All right? We don't know how far out from the center the interval of convergence is going to go unless we take a look at the graph, or we'll study how far out this interval will actually spread between these two curves. Any questions on writing a Taylor polynomial? All right, let's take a look at sigma notation. You knew sigma was going to come back. So a lot of times we'll express the formula for Taylor and Maclaurin polynomials in sigma notation. In order to use the sigma notation, you're going to have to find the general term. So if any time they ask you to come up with a Taylor polynomial and express it in sigma notation, you are going to have to find the general term. In order to find the general term, you are going to have to write out probably at least 3 or 4 terms, because you've got to see what the pattern's going to be. So in order to generate the general term for a Taylor or Maclaurin, you are going to have to write out the first 3 or 4 terms so you can establish what the pattern's going to be. All right, so again, when you're given this particular Taylor polynomial, remember this is going to be going out to the second derivative of x sub 0 times x minus x sub 0 to the second power all over 2 factorial. Plus, plus. It's going to be f to the nth derivative at x sub 0 times x minus x sub 0 to the nth all over n factorial. We've been dealing with infinite series for quite a while. When you're using sigma notation for a Taylor polynomial, notice my upper index is not infinity. It's n, because it has a specific start, it has a specific end. It's ending with the general term. All right? For your Maclaurin polynomials in sigma notation, remember you start with f of 0 plus f prime of 0 times x plus f prime of 0 times x squared all over 2 factorial plus plus your f to the nth of 0 times x to the nth all over n factorial. So again, if you have a Maclaurin polynomial in sigma notation, again, like I said, these have a definite n anytime we're talking about a polynomial. So that upper index is not infinity. We'll take a look at the power series when it is an infinite series later on. But again, anytime they're asking you to express a polynomial in sigma notation, that upper index is going to be a definite n, which is the nth term, which means you're ending with the general term. Okay? So we'll talk more about this after lunch. Particular Maclaurin polynomial. So again, that note, you're going to have to take it out, like I said, at least 3 or 4 terms so that you can establish what that pattern is going to be. And then they want you to express it in sigma notation. So because this is a Maclaurin polynomial, what do you know about the center? The center is going to be where? 0. So like I said, they're not going to tell you, if they tell you to generate a Maclaurin polynomial, you need to remember that the center is at x equals 0. So then, to find my Maclaurin polynomial, so it's two answers are going to be here. You have the nth Maclaurin polynomial, and then you want to write it in sigma notation. So I know it's going to be f of 0 plus f prime of 0 times x plus my second derivative at 0 times x squared over 2 factorial plus f to the third of 0 times x to the third over 3 factorial plus dot 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 plus. The nth Maclaurin polynomial will be f to the nth of 0 times x to the nth over n factorial. So that's the Maclaurin polynomial we're trying to write. So again, they're giving me my function 1 over 1 minus x. So f of x is equal to 1 over 1 minus x. So I need to find f of 0. What is f of 0 going to be equal to? 1. So now I need to find f prime of x. Oh boy, got to remember how to do this derivative. So again, if f of x is 1 over 1 minus x, I can write this as 1 minus x to the negative first. What rule are we going to have to apply in order to do this derivative? Chain rule. So this derivative is going to be what? So it's going to be negative 1 times 1 minus x raised to the negative second times what? Negative 1. So really this is going to be 1 over 1 minus x to the second, correct? Okay. Just remember how we do those derivatives here. So we have 1 over 1 minus x to the second. So then I need to know what f prime of 0 is going to be. F prime of 0 is also going to be what? 1. So remember, f prime of x can also be written as 1 minus x to the negative second. So what's my second derivative then going to be? My second derivative is going to be what? 2 times 1 minus x to the negative third, or 2 over 1 minus x to the third. So then my second derivative is going to be equivalent to what? 2. Third derivative. What's the third derivative going to be? 6 over 1 minus x to the fourth. So now f to the third of 0 is going to be what? 6. Now thinking ahead, the fourth derivative would be what? 24 over 1 minus x to the fifth. Notice those numbers I wrote on the board in terms of factorial. All right? So remember, 2 is actually equivalent to 2 factorial. 6 is equal to 3 factorial. If I was to find the fourth derivative at 0, that would also be 24, which would be 4 factorial. And like I mentioned, 1 is actually 0 factorial, 1 is actually 1 factorial. So now I can start writing my Maclaurin polynomial because, again, f of 0 is 1, plus f prime of 0 is going to be 1 times x, plus the second derivative at 0 is going to be 2x squared over 2 factorial, plus the third derivative is actually going to be 6 times x to the third over 3 factorial, plus dot 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 plus. So notice what's happening with the coefficients in this particular Maclaurin polynomial. This is 2 factorial, this is 3 factorial. So then when I go to write my general term, I know it's going to be my k factorial times x to the k all over k factorial. Or you could use n. I just used a k there. I don't know why, but I should have used an n. So then what is the general term then going to be for this particular Maclaurin polynomial? It's going to be just your, again, you don't have to simplify this. You can leave it as 2x squared over 2 factorial. It's just going to go down to x squared plus x to the third plus dot 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 plus x to the n. But like I said, you need to take it out a couple terms so that you can see what that pattern is going to be to help you generate the general term. All right, so any questions on finding the nth Maclaurin polynomial for 1 over 1 minus x? So now to express this in sigma notation, so again, I'm going to start with my lower index of n is equal to 1. Remember, it is a polynomial, so it has a definite n. It's not going to be infinity on the top, but you want to make sure you use a different letter here. So I'll use a k, and that's just going to be x to the n. So there it is in sigma notation. So in writing your Taylor or Maclaurin polynomial in sigma notation, you just take that nth term or general term. This is the formula, again, that would generate and this should be a 0. I don't know why I wrote a 1 here. You're starting with the 0 term. Most of them will start with the 0 term. Occasionally you'll see where you'll have to start with the first term. All right, so any questions on that one? All right, let's take a look at the next one. Find the nth Taylor polynomial for 1 over x about x equals 1 and express it in sigma notation. So again, my center is at 1. So again, I want to find my nth Taylor polynomial. So that means I need to find the general term. So again, to find my Taylor polynomial with the center at 1, it's going to be f of 1 plus f prime of 1 times x minus 1 plus the second derivative at 1 times x minus 1 to the second over 2 factorial plus f to the third of 1 times x minus 1 to the third over 3 factorial plus dot 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 plus f to the nth derivative of 1 times x minus 1 to the nth all over n factorial. So they're giving you that f of x is 1 over x. So what is f of 1 going to be? F of 1 is going to be what? 1. The first derivative. What is the derivative of 1 over x? Negative 1 over x squared. So then my first derivative at x equals 1 is going to be what? Negative 1. F to the second derivative is going to be what? 2 over x cubed. So then the second derivative at 1 is going to be 2. Third derivative. So it would be negative 6 over x to the fourth. So the third derivative at 1 is going to be negative 6. I'm thinking ahead. If you wanted to find the value of the fourth derivative at 1, what would that fourth derivative be at x equals 1? 24. Okay? So now I'm ready to go ahead and start generating this Taylor polynomial. So f of 1 I found to be 1. F prime of 1 I found to be negative 1. So I can write this as 1 minus the quantity x minus 1. The second derivative at 1 was 2 times x minus 1 to the second over 2 factorial. The third derivative at 1 we found to be negative 6. Plus dot 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 plus. Now what's unique about this Taylor? Not only would I write the general term, I'm going to have to include that alternator. Because notice I do have these terms alternating signs. So again, notice I've got this 2 in the numerator, which I know is equivalent to 2 factorial. I've got a 6 in the numerator, which I know is 3 factorial. And again, when I wrote out 24, I know that that's equivalent to 4 factorial. So I know my general term then is just going to be, those factorials will cancel out, so I know it's going to be an x minus 1 to the nth. Now the question is, if I'm starting with 0, and I want the first term to be positive. What's the exponent for this alternator going to be? Is it going to be a -1 to the nth or a -1 to the n plus 1? To the nth, because we're starting with 0, remember? So then, if I want to write this Taylor polynomial, I know it's going to be a 1 minus x minus 1 plus x minus 1 to the second minus x minus 1 to the third plus dot 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 plus -1 to the nth times x minus 1 to the nth. So there is your nth Taylor polynomial. So then in sigma notation, n equals 0 as the lower index to k, and I just replace the formula with that general term. So there is your Taylor polynomial for that one. So any questions on, so again, it very well may happen, you have to include an alternator as part of your Taylor and Maclaurin if the signs are alternating. All right, so any questions on that? All right, let's take a look at the next. So now here's some variations on questions they may ask you about Taylor and Maclaurin's. So which of the functions graphed in the following figure is most likely to have p of x equals 1 plus x minus 2x squared as its second order Maclaurin polynomial? So first of all, Maclaurin polynomial, I know the center is at x equals 0. So think about what a second order Maclaurin polynomial is. It means it's going to be taken out to the second derivative. So a Maclaurin polynomial to the second order is going to look like this: f of 0 plus f prime of 0 times x plus the second derivative of 0 times x squared over 2 factorial. Get in the habit, guys. Anytime they ask you questions about Maclaurin and Taylor, write this formula out. All right? They generated the Maclaurin polynomial for you. They've given it to you as 1 plus x minus x squared. That's what they gave you. So I know in a Maclaurin polynomial I start with f of 0. So based upon the Maclaurin polynomial that they gave you, what is f of 0 equal to? F of 0 is equal to what? What? The second term in this Maclaurin polynomial is coming from f prime of 0 times x. So what is the term f prime of 0 times x equivalent to in this particular Maclaurin polynomial? That's equal to x. So then what is f prime of 0 equal to? 1. The second derivative at 0 times x squared over 2 factorial would be the third term in this particular Maclaurin polynomial, which is going to be equivalent to -2x squared. Solve for the second derivative at 0. So I know the x squares are going to divide out. So what is the second derivative at x equals 0 going to be equivalent to? What's it going to be equivalent to? -4. Okay? So when they give you a Maclaurin or Taylor polynomial, a lot of these questions you're going to have to be able to solve for the value of the derivative. So now, graphically, let's talk about the first derivative. When the first derivative is greater than 0, graphically, what do we know? Graphically, this function has to be what? Increasing or decreasing. So I know that I'm looking at a graph that has to be increasing. When the second derivative is negative, that tells me about the concavity. So when my second derivative is less than 0, what do I know about this graph? This graph has to be concave what? Down. So my answer choice has to be the graph that is increasing, because f prime of 0 is greater than 0, and it has to be concave down. because the second derivative at 0 is less than 0. So which answer choice, and again, obviously, I know that I have to have that condition f of 0 is equal to 1. So which one of these graphs is going to satisfy all three of those conditions? 2. Okay? So any questions on that? It's a very common AP question. You will have, I can tell you this, on your AP exam, there is one whole FRQ dedicated to Chapter 9 involving Taylor-Maclaurin. You will have one FRQ based on Chapter 9. All right? So there's, as BC always has one, you'll have one from Chapter 10 as well. 2 of your FRQs come from it'll be a polar, vector, or parametric question. Past 2 years, it's been polar. Okay. Depends on what you remember about your polar. But we'll review polar. Okay. All right, we good on that? Okay. Sometimes they're even nicer to you. So notice they're giving you values of a function and the first 4 derivatives at x equals -2. They've actually already found the value of the first 4 derivatives, so you don't actually have to find the derivative and then plug the number in. They're giving it to you. We have no idea what f of x is. They want us to find as many Taylor polynomials for f as you can about x equals -2. Will this be a Taylor or Maclaurin? Taylor, because my center is at x equals -2. So again, always write out how you generate a Taylor-Maclaurin polynomial. So again, I know I start with f of -2 plus f prime of -2 times x plus 2 to the second, or first, excuse me, plus the second derivative at -2 times x plus 2 to the second over 2 factorial. They're taking this out to the 4th derivative. So the third derivative at -2 times x plus 2 to the third over 3 factorial plus the 4th derivative at -2 times x plus 2 to the 4th over 4 factorial. Some of you are not going to heed my advice very well. Say, you know what, Ms. Berge, I do not need to write this out. You just don't want me wasting my time and my paper. And then you're going to stare at a problem and you're going to make a careless mistake. Trust me, it happens. Most of the time, if you write this out, the answer is going to be sitting you right in the face. If you just write it out, you'll be able to answer most of the questions. Those of you that don't want to write it out are going to look at a problem and make a careless error. All right? Always, always, anytime they ask about Taylor-Maclaurin, write this out. So now, I'm taking this out to the 4th degree. They're telling you what f of -2 is equal to. What is f of -2 equal to? 5. They're telling you what f prime of -2 is equal to. That's equal to 0. They're telling you what the second derivative is equal to. The second derivative is equal to what? -2. They're telling you the third derivative is equal to what? 7. And then finally, they're telling you the 4th derivative is equal to what? -9. And like I said, do not simplify. Leave it alone. That's it. If you obviously did not write this second term, that absolutely would be fine as well. All right? So any questions on generating that one? So like I said, have no idea what function this polynomial represents. It may not represent anything. They randomly just found the numbers for you. You guys go ahead and try the next one. So again, the next one is a Maclaurin. So go ahead and generate the next one for me. Like I said, you do not need to simplify the factorials. You do not need to simplify the fractions. In fact, I encourage you not to. All right? So any questions? I mean, I wouldn't mark off if you did, as long as you simplified correctly, but I'll warn you, if you do simplify and you make a mistake, I have no choice but to take off, and they will in the AP exam as well. So that's why you're better off not simplifying these. Any questions on example 10? So the last 2 examples, they actually gave you the values of the different derivatives. Sometimes they may actually, without giving you the function to generate a Taylor or a Maclaurin, they may give you a formula to calculate the value of the derivative. So for example, take a look at the last example. Again, they're telling you that f of 2 is equal to 7, so there is telling you the center. What's the center of this particular polynomial going to be? The center is going to be at x equals what? 2. So when n is odd, the nth derivative of f at x equals 2 is 0. So again, the nth derivative at any of the odd derivatives is going to be 0. So the first derivative is 0, the third derivative is 0, the fifth derivative is 0. So any of your odd derivatives is going to have a value of 0. When the derivative is even and n is greater than or equal to 2, the value is given by this particular formula, n minus 1 factorial divided by 3 to the n. N, remember, represents the derivative. So the second derivative can be found by plugging 2 in for n. The fourth derivative can be found by plugging 4 in for n. The sixth derivative can be found by plugging in 6 for n. So they want me to write a 6-degree Taylor polynomial about x equals 2. So again, I'm writing my 6th derivative. Now, since the value of my odd derivatives are all equal to 0, what's going to happen with all the odd powers? All the odd powers are going to do what? Cancel out. So the only thing that's going to be remaining are the even powers for x in this particular Taylor polynomial. So I know that the 6-degree Taylor polynomial is going to be f of 2 plus the first derivative will cancel out because it's odd. So I'll have the second derivative at 2 times x minus 2 to the second all over 2 factorial. Plus, the third derivative is going to cancel out because it's odd. So the next one's going to be f to the fourth of 2 times x minus 2 to the fourth all over 4 factorial. Again, they want you to take this out to the 6th degree. So make sure you take it out exactly as far as they want you to write it. The fifth power is going to cancel out. So I'll be left next with the 6th derivative at 2 times x minus 2 to the 6th all over 6 factorial. So now let's find the pieces I need. What are they telling you about f of 2? F of 2 is equal to what? 7. So now I need to find the value of the second derivative at 2. So they're giving me my formula, so I'm going to plug 2 in for n, so 2 minus 1 factorial over 3 to the second power. So I know that's just going to be equivalent to 1/9. The fourth derivative at 2, I'll plug in 4 for n, so I'll have 4 minus 1 factorial over 3 to the fourth. And again, it's okay to leave this as 3 factorial over 3 to the fourth. And then finally, your 6th derivative at 2, 6 minus 1 factorial over 3 to the 6th. So 5 factorial over 3 to the 6th. So like I said, sometimes they'll give you formulas where you'll actually have to calculate the value of the derivatives. All right? Or they may just be really nice and give you the value of all the derivatives like they did in the other 2 examples. All right? So any questions on how I found the value of those derivatives? So now I'm ready to plug them into my Taylor polynomial. So my 6th degree Taylor polynomial, f of 2 is 7. I found the second derivative to be 1/9. So it's going to be 1/9 times x minus 2 to the second over 2 factorial. Plus, the fourth derivative at 2 we found to be 3 factorial divided by 3 to the fourth. So I can write this as 3 factorial over 3 to the fourth times x minus 2 to the fourth over 4 factorial. Plus, the 6th derivative at 2 I know would be 5 factorial over 3 to the 6th times x minus 2 to the 6th over 6 factorial. question, they would probably clean up these factorials on you. Because if you take a look right here, I've got 3 factorial in this numerator, 4 factorial in this denominator. So remember how we simplify factorials. You can take 4 factorial and write it as 4 times 3 factorial and cancel the factorials out. So they would probably clean up, because those aren't too bad to simplify those factorials. But again, if it's free response, you don't have to touch it. But just know on multiple choice, they would simplify those factorials on you. All right, so any questions on that example there? So any questions on writing Taylor or Maclaurin polynomials? Like I said, you only have to find that general term